Okay. Six point 4 operational amplifiers. Amplifiers. Yarkın, what is operational amplifiers? What is the meaning of the operational? Suzan? Mathematical operations. Zülküf, which operation can be considered as the mathematical operation? Could you give me an example of it? Yes, integral, but the mathematical operation, simplest arithmetic operation, summation, subtraction, division, and multiplication. And also, just like Zülküf said, integral and derivative operation. We need to use op-amp. Okay? And so, how we can write the op-amp? Just remember the analog electronic lesson from online sessions. Okay? Minus, plus, A, B can be given in here, and we have the watt, the input voltage in one side, right? V in, right? And so this is going to the what, the minus attachment in here, right? And also plus is connected to what, the ground, right? And we should give the what, the resistance in here, just like this one, Ri, and also we should give the what, the another resistance in here at the end of the op-amp. This is the what, V out. This is the RF, right? And so, what is the rule to solve this op-amp equation? Anyone remember about the infinite open loop gain? Infinite input impedance, zero output impedance. What's the meaning of this? It means that in simple case VA VB, right? The voltage of A must be equal to the what, voltage of B, right? But why? Which condition should give us? ZA should be equal to what, the infinite impedance. ZO is equal to what, the zero impedance, right? Which one is equal to the which condition? Zozan, I think this zero output impedance is equal to what, to this one, because zero is seen on the right hand side, and so infinite input impedance, Z is impedance, and I think this infinite value is related to this one. And also infinite open loop gain means that the VA must be equal to the VB, right? Right? Okay. So we should write the currents in here. We have I1 in here, and we have I2 in here, and we have I3 in here. This one is 0 because it's going to what? The ground. Okay. And so, what is the value of the I3?
Is it almost 0?
Yes.
Because of the high impedance in the
Because high.
impedance.
Yes. This ZA is going to what? The infinity value or equals to the infinity. And so I3 should be equals to what? 0. This is the ideal op-amp, right? And so we can write this equation I1 must be equals to what? The I2 plus I3, which is coming from the what? The Kirchhoff law, right? This is the Kirchhoff law. But in this condition, I1 must be equals to I2, right? Right? Okay. And so what is the values of the I1? How we can calculate it? Huh? No.
VA minus VN over R1 RI.
This is the direction of I1, and so V in minus VA divided by RI. What is the I2? Just tell me. What is this point? VA. VA minus divided by RF. What is the value of VA? What is the VA? Huh? What is the VA? Abi baksanıza şuraya. VA must be equals to the what? VB. What is the values of VB? Huh? Yes. And so VA? Huh? Okay. Thank you. And so our equation turns into the what? Into the this one. VI divided by RE must be equals to the what? This is the I1. What is the I2? Minus V0 divided by RF. And so we can write to the what? To this equation. V0 must be equals to what? Minus RF divided by RI times VI. And so, which is called to the what? Which type of amplifier can be used in this case? This is amplify, right? With a proportional one. And so this is the proportional op-amp. We multiply the input signal with the another one, or the R coefficients, RF divided by RI, right? Right? Any question about that? Huh? Any question? No question? Everyone gets the everything about the op-amp right now? Okay. We should consider or this one. In normal case, we can build the PID controller based on these terms in here. Suppose that we have the signal R1 and we have the op-amp value R2 in here. So we have V0, Vi, okay? And also we have the ground in here connected to this one, okay? This Vi and V0. What is the V0 in here? Times Vi, or we can assign the ET in here instead of using the what? The Vi. ET is also a voltage in here, but the error voltage in here. And so this is the ET, This is the V0T, and so this is called the what? The proportional op-amp. This is the first one. In the second one, we can build the what R3, and we can build the what the op-amp in here, and also this one V0. But we may use the what the C1 in here. Capacitance. How we can solve this equation right now? First of all, you need to put the what the currents in here, just like this one, I1, and this is I2, and this is I3, right? We should put the currents in here, and after that, this is to what? This is the ET, this is the V0T, okay? And so we should write to what each voltage value. I1 is equals to the what? Yeah? Yes, but in the voltage form, how we can calculate in terms of the resistance and voltage values in here? Minus 0, because this is 0 voltage, this is also 0 voltage, right? And so ET divided by R3, right? And so what is the I2? Huh? Yes, 1 over C. No, this is the minus C times V0 dt, because this is 0 and 0 minus V0, which is equals to minus dV0 dt times C, right? This is the simple equation. Okay? So if this is the case, and so I1 is equals to the I2, right? And so C times dV0 dt must be equals to what? The minus ET divided by R3, right? And so we can write dV0 dt is equals to what? The E divided by R3 times C1, right? Right? Yes, we have minus in here. And so, in terms of the what, the Laplace domain, we can write this equation just like this one. S times V0, right? V0 S must be equals to the what? ES times minus 1 R3 times C1. Or V0S is equals to the what? Minus R3 times C1 times 1 divided by S times ES, which means that this is what? Huh? Nay? Yes, integrator. This is proportional. Okay? So, how about this one? Capacitance can be built in this case, and so we have one resistance in here. This is the C2, this is the V0, Vi, or in this case the error signal, okay, ET. And so how we can solve this equation right now? First of all, we need to write to what? Yes, I1, I2, and I3, right? And so I3 is equals to 0. This is 0 voltage because it's connected to the what? The ground. And so, what is the values of the I1? How we can represent this I1? Zozan? Huh? No. Huh. C times dE dt, right? This because the E minus 0 divided by dt times C is equals to the I1. What is the I2 in here? Huh? VO, but 0 minus VO divided by R4. And I1, I2 is equals to what? Each other, right? And so if this is the case, if we combine the equation, and then we can write that the VO must be equals to what? Minus R4 times C2 times dE dt, right? These are the equation. But in the S domain, we can write to the what? V0 S is equals to what? Minus R4 C2 S E S, which is equals to the what? Derivative. We can take the derivative values of these terms, just like this one. See? This is how we can build our operational amplifier mode. In terms of the what? In terms of these equations. Okay? Okay. So, in the last topic, we need to build the DC motor model, which is important. Okay? In the DC motor, we have two parts, guys. Two parts. First of all, the mechanical one. The other one is the electrical one, right? In the mechanical one, we have the rotor, right? And rotor possesses what? The mass or the inertia, right? J or M or C, because we have the friction or the damping ratio in here, right? In the electrical one, we apply the current or the voltage to this system in order to what? In order to activate the system. And we have the components of the what? Kim söyledi onu? Yes, but the J, M, C, L, yes, and R, resistance. Okay, so we can model these terms just like this one. We can build this mechanical part just like this one. Okay, we have the C value in here, which is the ground. This is the mechanical part, and so if this is the mechanical, we have the J, inertia values in here, and also we can apply the torque value, which is coming from the what? Coming from the electrical part, right? And so we have also W value in here. This is the angular speed, right? And just like your friend said, we have the IF stator values in here. This is the field current, right? And we have the field inductance LF and IF value in here. But this is the static part, okay? We don't need to use this field current in here, but always we will focus on to rotor part, which means that it's the armature part, okay? VA and RA and LA, and also we have the back EMF current in here, VB, okay? And so this VB is created due to the what? Due to the rotation of the magnetic field in here, okay? And so if we apply the voltage, and we can generate the current, and this current is applied on the what, or generates the VB, okay? This VB activates the rotor speed because the rotor is affected by the magnetic field. Okay, this is called DC motor, Zozan, right? And so in this case we have the IA value in here, just like this one. This is the current, armature current, and so we can write this one. We should create the torque based on what? The electrical current, and the formulation of these terms is equals to the what? The N B L R times IA is equals to the what? The KT times IA. What is the N in here? Number of armature coils. Okay, number of coils. What's the B? Just remember the physics lesson. Huh? Flux density. Right? What is the L? Length of armature. Okay? What is the R? Radius of armature. The test about the test on the DC motor shows that this can be built as a constant. It's the approximation values of the KT. This is called the motor constant. Okay? And this motor constant is built with the what? With this information. In the test, we apply the different current in here, just like this one, and we can measure the torque. And so it is going to do what? The linear curve, just like this one. Okay? And so if you look at the data sheet of these values, and so this KT can be approximated by using these terms. Okay? This is the first equation. This is the conversion of the what? The current to torque. Okay? Yarkın? That's good. Okay. And so how about the other one? The VB, back EMF voltage in here, is also N, B, L, R times W, angular speed values, or this is equals to what? The KB times W. KB is close enough to the what? To the KT value, but it is related to what? The W value, or the angular speed value. Okay? So we can build this model based on this information. First of all, we can write that. If we have this information, we apply the VA, armature current, in here, just like this one. Minus RA is reduces or consumes the one energy, RA times IA, right? And the other consuming part, LA times DIA dt, must be equals to the what? Must be equals to? Huh? Just see the circuit. Huh? Yes, but the VB is equals to KB times W, right? Okay. And so, how about the mechanical part? This is the what? Electrical part. This is mechanical, right? This is the electrical. So, how we can write the mechanical part? Yeah? No. Just see that we have the inertia. This is the what? The I in here, for example, not the J. And so we should apply the what? The input. But which input? What is the input input type of the mechanical system? Zuzan? No. Huh? What is the input or the across variable of the mechanical system? No. Huh? Force, but in the rotational system? Huh? Torque. Lan şurada yazıyor ya. Böyle bir şey olamaz. Torque. KT times IA. must be equals to the what, Zozan? We have the inertia and the C, damper coefficients in here. We should consume the energy on the what? I times dw dt plus C times W. Right? We should give the energy form torque into the what? The I times dw dw divided by dt plus C times W. Right? One of them is the loss energy, the other one the preserving energy, the acceleration energy in this form. Okay? Huh? Yes, I is inertia. I A is the current. So, if this is the case, we can reorganize the equation. Just like this one. LA times DIA dt is equals to what? Minus RA IA minus KB times W plus VA. VA the input voltage. And also I dW dt is equals to what? KT IA minus CW. Okay? In the first place, we apply the VA and obtain the IA. And after that, IA generates the what? The W, angular position in here, in the DC motor, right? And so, taking the Laplace transform gives us to what? IAS is equals to LAS plus RA plus KB times WS is equals to what? The VAS, right? And also we have WS in the second place, right? SI plus C, because we take this term into the left side, and so KT times IAS, right? These are the basic Laplace transformation of this term. So, how we can build the block diagram in here based on these equations? How we can build it? Just remember the previous lesson. First of all, we have the what? The plant. What is our plant in here? What is the output of this plant from the block diagram? Zozan. What is the output? Huh? Yes, WS. And so, what is the input of this plant? Torque. And so, what is this? Yes, but we have 1 divided by IS plus C in here, right? Because this is equals to the what? This is equals to this one. No. This is coming from I dW dt plus CW is equals to what? The torque T, right? This is the basic mechanical equation. And so in the transfer function domain we have this one. And so how we can calculate the torque value? KT times IA, right? And so we have also another block in here, just like this one, which is input value of this term is equals to IA. And how should I write this equation? Huh? No, just KT. Okay. And so what about the IA signal? We must write also another transfer function, but this is the electrical one. How we can write it? What is the input of these terms? Huh? VAS, but just remember that VAS, IAS, but we have also a back EMF current in here, right? KB times WS, and so we must subtract this term from the what, the VA, and we should put the what, the plus VAS, and so we should take the feedback from the what, the KB WS in here, and so this must be going to the what, going to the this term LAS plus RA, which means that 1 divided by LAS plus RA should be written on this page, right? This is the block diagram for driving the DC motor, guys. Do you understand that right now, Zulkif? Okay. So if we have this information, and so we can write to the what, WS divided by VAS, right? But how we can do that? How we can do that? Just remember the previous week. No. What is the WS or the IS in here? See, WS is equals to the what? Huh? VAS minus KB times WS, right? Times this block 1 divided by LAS plus RA times KT times 1 divided by IS plus C, right? Because this signal is going to the what, to WS, and so we can multiply the everything in here because we are in S domain, right? And so if you solve this equation, this is your homework, VAS, you can reach to the what, to this equation, just like this one, KT divided by LAIS square plus RAI plus CLAS plus CRA plus KB times KT. Okay, these are the basic transfer function for a given the voltage value, how much increase the WS, the angular speed value in here. Okay, you must solve it, it's important. Okay, Yarkın, this is the transfer function one, but we can build this system in state space also, right? SS representation, which means that DIA divided by DT must be equals to the what, the minus RA LA times IA plus minus KB divided by LA times W and plus 1 divided by LA VA. Where is it coming from, this equation? Where is it coming from? Zozan? Where is it coming from? Huh? How we can write this equation? Zozan? It's based on what, the armature current or the electrical field or the electrical theorem it's coming from the what, this equation is written in the what, in the state space form. Okay. And also dw dt is equals to what, the kt divided by I times IA plus minus C divided by I W. Okay. This is the electrical part. This is the mechanical part. Right? See? So, what are the states? Yes. So, x1 is a dummy variable. IA, x2, Hajar, x2, x2. Just see that? This is the first derivative. And so, this symbol must be equals to the what? State. W. Okay? So, just help me to fill this place. x1 dot, x2 dot. Okay? What is the dimension of this matrix? Huh? Yes. What is the input? Huh? Yes, VAT. Okay. And so, just help me for the first term. How we can write this equation? And so, second. And so, this? Yes. And so? Yes. And so, what about the first term of the input? Yes. Yes. See? This is the z dot a z plus b mu. Right? That's the state space. See? But the importance of state space can be seen right now. We can combine the what? Electrical system with the mechanical one. See? It's a powerful method to what? To obtain your equation of motion in terms of what? System dynamic equation. This makes easier to solve your system in MATLAB or in real life. Okay? So, solve 6.44 and 6.43 examples or problem in Palm. Okay? And also write the MATLAB code for this. I will prepare the MATLAB video session on my playlist, but you should solve these equations as well. Okay? Any question? Any question?